So up to this point, does anybody have any questions around what we're doing, how we're doing it? So understand that this may not always be the most efficient way of doing it, but it's for demonstration purposes and trying to get you a perspective on how to do different things within the framework. And just so you get a feel for some of these structures as well. Alright, so I'm going to go ahead and just run this. I put a breakpoint here by clicking in the margin. So when you're in debug mode, what will happen is as you run, it'll run and then it'll stop at that breakpoint. It'll allow you to examine what's going on. So you kind of saw me doing this. So 300 divided by 3 times 10 equals, and this breakpoint will let me stop and examine the memory as it is right now. So we can mouse over calculation queue, which should have the pieces of our calculation stored. We have 5 pieces, we had 5 elements, so that's at least a good sign. If we expand it, we see 300 divided by 3 times 10. The inputted equation was 300 divided by 3 times 10. Okay? So it parsed the way we would have expected. So it went through a number, a character at a time, rebuilt those numbers, and gave us back what we need. So everything's good, so we got true. If we do e times 8 plus b, we had an exception occur. I don't have a message, so we'll have to make an adjustment for that. So in here we'll say else console dot writeline that equation. Or it'll tell me it's good. So through this we could do one final step. Validate the elements of the calculation. So my hesitancy is that since we're using a queue, if I start popping elements or dequeuing elements from this, then we'll end up losing them to validate them. So we have a few options of how we can go about this. So we come up here and we determine if there's a number there. Inside of this, we could also go ahead and say float, because now it's a float, dot try parse, or there's the potential for a float, it could be decimal, and number out, let's see, what did I call it up here? We'll just call it float val. So we'll declare float val. This will be our catch for our try parse. So if this parses, go ahead and queue up the number. It's good. Else, we can return false. Invalid number provided in equation. It actually does both. Try parse, the method will return a boolean whether or not true or false if it could do the parsing. And then this out float val, if it's yes, then it puts the value in there.
Okay.
So,
Okay.
Yeah. If you just do a parse, then parse will take whatever the string is and assume that it can parse it and then return you its value. this does the both. So that way, if it's not parsable, you don't end up blowing up the app or having to wrap it in a try-catch block if the parse doesn't work. So if this number is a number, we'll store it, and if it's not, then we'll say that this is an invalid equation and return false. So let's try one more time. So e plus b, bad equation. E plus 2 still says it's good. Why does it say it's good? So we'll put a breakpoint here. Let's run e plus 2 again. Okay, this is execution order problem. Let's stop. I'm going to do the int check last. So this piece about storing the number and everything happens when it runs into an operator. If we assume that our equation isn't going to start with an operator, which it shouldn't in most cases, or if it does, we'll probably just drop it off. We want to first, as we're looping through, you think logically, okay, I hit E. E is not an operator, it's not a decimal, and it's not a number. So if we check in that order, is this either a decimal, an operator, or then a number? We'll check all three. The last test is to say, is this a number, and we attempt to parse it. If the parse fails, then it's not any of the three above, and therefore we'll throw false. Otherwise, what's happening right now is the first step is it's checking to see, is it a number? It says, no, it's not a number. The next step says, is it a dot? It says, no, it's not a dot. Last step is it an operator? We say, no, it's not an operator either. So because it's not one of those three, we just let it flow on by. Where in fact, the last check should be, is it a number? And if it's a number, we store it. And if it's not, then we say this is a bad equation. And this will also help us if we were to type in 2e plus 3b, you know, that kind of a thing, because it's going to run into these letters in the middle of its equation. So if we go e plus 2, now we get bad equation. 2b plus c divided by 3a, bad equation. 3 plus 3. It'll do the parse. And it's now a bad equation. Okay. As you're doing your debugging, there's a debugging toolbar that appears. I've got it here, so it leads off with the play, the stop, restart, and then these allow you to step in and through your code. So we can actually have this, if we do a step over, it won't go into this execution line, it'll actually let it execute and then go into the next line. So this is saying that the value examined, this was a true statement, therefore we come down to this line. So 3 is stored after that line executes. So a number now has 3. And then if we go ahead and step into, we'll go back to the while, go to the next line, pull the next character off. This is a plus sign, so it's an operator. A number has a value. it'll queue up that value, reset a number, add the operator. So we now have two values in here, 3 plus. Okay. So another piece of our logic is, now that we've added that operator, we need to continue. Otherwise, we'll fall through and then start doing the number check, which we don't want. Same thing will happen with here, so we'll do a continue. So if we run this one more time, we now have 3 plus 3. Alright. So now we have our equation in our queue. The next step is to do the calculation. So this is pretty simple and should be relatively comparable to what you were doing with with what you did in your assignment. I'm going to create a method called doMath, and it will take in value 1, value 2, and the operator. And we'll use a switch case for the operator. We'll first validate. If it doesn't, we'll return NaN, or not a number. And we'll switch through the operators. So case plus, actually these are break, case minus, case times, case, divide, and then the alternate case for divide, and the defaults. Alright, so here we do our basic equations. And we'll say return, we don't need our breaks, return val 1 plus val 2, return val 1 minus val 2, return val 1 times val 2, and then we'll return val 1 divided by val 2. Complaining that this is a character array. I was bringing in strings, so I changed it to a character so that this would work, and then just changed the double quotes to single quotes using a highlight, Control H for find and replace, search for double quotes to single quotes, and replace them. Alright, so what we need now is we need to go through our queue and capture our math and do the math. Now, I'll preface this by saying, we're not handling order of operation appropriately. We're basically doing the math from left to right, so everybody's cool with that before we get too far into this. Okay. So we have our calculation queue. So while there's things in the queue to be processed, so what we're going to run into is a few scenarios. If the queue has one value, which means that we probably type just a number in, we need to output that one value. If the queue has three values, that's a val 1, oper, val 2 scenario. Simple enough. The third scenario is if we has more than three values, which then is a val 1, oper, val 2, oper, val 3. You get the picture. In this case, we'll say if that count equals one value, we'll simply return now. I'm going to have enough faith that we've done enough try parse and parse checking and all of those things that at this point I can simply say float.parse and parse that value out and then return it. Cannot convert to position. Oh, sorry. Okay. So if we have one value, simple enough. We just return the one value. If we have three values, then personally my approach would be to do val1 equals calculation q dq, oper equals calculation q dq, val2 equals calculation q dq. And then we'll return do math on val1, val2 on the operator. If we have more than that, in this line when we DQ, we're DQing that operator. We're DQing it as a string. We cannot take a string and store it into a char data type, because a char is a single character, a string technically is more than one character. So if you read this line, the way you should read it is we're taking the Q and we're DQing it. It's going to give us a string back, making the assumption that the value that's being returned is a one character string. We're then going to take that string and take the first position of that string, which will return us that first character. Does that make sense to everybody how to read that? Okay. And then we'll do a float parse on the last character, so that'll give us all three pieces. I'm thinking of actually combining these two because there's a lot of overlap that's going to occur here. So what's going to happen is, assuming we only have 3 values, we're going to dequeue those 3 values. That means there's nothing left in the queue to process. So when it's all said and done, we'll simply pull out these 3 values, have nothing left, the while loop will never execute, and then we'll do the math on the final piece. Return that final value of value 1, operator value 2. If there are more than 3 values in the queue, then what we need to first do is this same line of code. And then calculate the new value. And then what I'm going to do, or propose that we do, is take val1 and set it equal to the result of the calculation. So think of it this way: if we have 2 plus 2 plus 2, the first step is we pull out 2, we pull out the plus, and we pull out the 2. We step into here because we know that we're going to have more math to do, that we need to do this recursively in a loop, essentially. So the first thing is we do 2 plus 2, which gives us 4. We store 4 in value 1. We're then going to dequeue the next operator and the next number, let this loop repeat, and then we'll now have 4 in val 1 plus, and then 2 in val 2. And we keep continuing that process until we get through the queue. When it's all said and done, we'll have the answer in val 1. And I'm going to think about how we get from there to where we need to be. So, that being said, we'll go on the journey. So we now have the new answer here. We'll then take the operator, we'll dequeue the next operator, and we'll parse the next value. Alright, so here's what we're going to do. Alright, so by flipping the while statement upside down, what will happen is, logically, we're saying that we have at least 3 values. So we'll take out value 1. So let's again go through 2 plus 2 plus 2. Value 1, 2, first operator plus value 2 is the other 2. The next step is do. So it will do this loop at least one time. We'll then say do math on 2 plus 2. It will return 4. If there's any items remaining in the queue, dequeue the next 2 items. We dequeue the next 2 items. It's then going to check if there's any items remaining in the queue, which is not what we want. Alright, anybody have any ideas? Don't be shy. I've taken 2 stabs at it already. We're assuming that there's at least 3 values, yes. Because I said so. Go back and listen to the lecture. I'm just kidding. All right, so look at it as a look at it like this. Just look at that part in blue. The part in blue will return a string to us. So when the compiler, when the computer goes and interprets this line, it's going to do it in 2 steps. The first step is going to be get string from DQ. The second step is get char 0 from string. Does that make sense now? Okay. Right. Anybody have any ideas? I've got one more, but I'm just waiting to see if anybody else has one. Okay. My last attempt is while true. I'm going to move this in here. Now I'm going to do that. I didn't be able to leave that out there. Alright, so here's my method to my madness. We'll start off again with 2 plus 2 plus 2. If we start at line 127, we're going to pull 2 off the stack, or 2 out of the queue, pull the plus, pull the 2, right? So we have 2 plus 2. We enter the loop. The first thing we do is we do the math of 2 plus 2. If there's only 3 values in the queue, the 2, the plus, and the 2, the next line will be false. What? What was that? Right. So maybe this line is not what it needs to be. So let's leave that as it is. We need to figure out what that last piece needs to be. All right. So, all right, so let's start at the beginning. So we have 2 plus 2. Everybody's same on that. We step into the loop. We do 2 plus 2. We now store 4 inside of val 1. We have no additional values, so we break out of the loop. So then the gut says this is val 1. Everybody feel the same way about that? Okay. So let's go 2 plus 2 plus 2. So 2 plus 2 gets us to here, gives us 4. We have 2 more values in the queue, another plus and another 2. If we dequeue both, we loop back again, we now have 4 plus 2. We do that, we get 6. We have no more items in the queue, therefore we break, and this should be equal to 6. Does everybody feel good about that? That logically seems to work? Alright. Alright, compiler isn't complaining. That's good. So, we'll give it a test run. 2 plus 2 is 4. Alright. 2 plus 2 plus 2 is 6. 2 times 2 is 4. 2 times 2 times 2 is 8. 300 divided by 10 times 2. 300 divided by 10 is 30. 30 times 2 is 60. Check us out. Alright. There you go, Chris. I did your homework for you.
What about divide by 0?
Oh, divide by 0. We'll probably throw a math exception. 5 divided by 0 is infinity. 1 divided by 1. 300 divided by 300. Check that out. Calculator. Alright. So, how's everybody feel about that? Fancy, way too complex?
There's lots of digest in 2 hours.
Huh?
There's lots of digest in 2 hours. Lots to go back and watch the videos.
Okay. Well, that's
It wasn't anything too far out. It was just.
the complexity around making it happen. Yeah. And
It's not enough actually to see like the machine being used.
Yeah, we've never.
oh, okay.
Not like just
In theory.
talking about the theory of it.
Yeah.
Yeah, we've never applied it. We talked about it, we never actually applied it.
Oh, okay.
So-
More about application. All right. So there's a calculator. So has anybody ever used Wolfram Alpha? Okay. So Wolfram Alpha, you basically go in, you type an equation in there, and it does some math and spits you out a value. Conceivably, this is the basic mechanics of how that works. It's obviously more complex. You have to deal with parentheses and all those other pieces, but there you go. So how would you think that we would handle if we did appropriately handle parentheses and appropriately handle order of operation? Any ideas?
Start checking no parentheses and what the operator actually is before you do that.
Mm-hmm. At what point would you do it?
Well, first hit the parentheses
Yes.
first. Usually make it itself. But like, I can like visualize it. I just can't visualize how you check if there's like any parentheses. So like you check like is there an open parenthesis, start the queue, queue up what's in there, do the math. If there's no more numbers or anything in there, spit that out, and then you'll have a value left for whatever that was.
Mm-hmm.
Just keep going.
Right. Right. So that's kind of where the stack comes into play, the way that I've seen it, is you start with your equation, and then you start putting into the stack all of the big basic math components. So if you have 2 plus the value 2 plus 2, I mean obviously you get the same math, but you would take the 2, you put it in the stack. You take the plus, you put it in the stack. You then run into a parenthesis and you go, hold on, I have to run that as a subset unit by itself. So you would take that whole chunk and store it in the stack. Then you continue adding your other, or I'm sorry, no, you set it aside and you continue adding the other pieces, kind of leaving a placeholder for that basically. And then the last step is you take whatever's in the parentheses and you put it in the stack. So then when you start pulling values out, the first thing you do is you execute what was in the parentheses, and you get a number. Then you take that and then you sort by order of operation, and you take that number out and you start doing order operation on it. Doing your multiplication, then your division, then your plus and minus, and exponents are obviously in there as well. So there's a lot of like sorting and filtering and trying to keep pieces together in order to do the order of operation. You guys want to do that for homework? Come on, this only took 2 hours.
I think you go from having a class of what, 5 to a class of 1.
Who's gonna stay?
The nested parentheses is not
Huh?
nested parentheses, so I just put a whole bunch of.
Uh-huh. Yes. And then you end up with recursive calls in order to deal with the nested parentheses.
Last year, the first thing we did programming through. Last semester, all it was recursion.
I love recursion.
A little slow sometimes,